All right, so in our circuits, we're not always going to have batteries as our source of power. Sometimes we're going to have these current devices or current sources. And it's just drawn by this. It's a little circle with an arrow telling you which way the current is. And it's going to tell you that it's going upwards at 2 amps. So it might be drawn like this, left to right. So the current's moving left to right here at 2 amps. And we just see that we have some current going into the 2 ohm and some current going into the 1 ohm. And as we know earlier too, we're going to have most of our current, 2/3 of our current go this way and 1/3 go this way. Now what happens if we have these current devices in parallel? So we have 3 amps in parallel with 2 amps. And all these are in parallel, so we could rewrite them in any way we want. So we could put the 3 amps here and the 2 amps here, and then the 2 resistors over here if we wanted to. Or we could do it the opposite way. You can write it as many ways as you want, as long as you keep them all parallel. But we end up seeing that we can combine them if they're going the same direction by adding. So we end up getting 3 amps plus 2 amps to give us a 5 amp current source with our two resistors still in parallel. Now what happens if we have these one going one way and one going the other way? As we know with current, we could just rewrite this as -3 in the same direction. So then we could take our 5 minus 3 to give us 2 amps. So this could then be rewritten as 2 amps. Still in parallel with these resistors, remember. So then let's look at the voltage for this circuit here. So if we combine these resistors, we know that 3 ohm plus 2 ohm, since they're in series, will give us 5 ohm. And then our 5 amps times 5 ohms will give us 25 volts for this circuit. All right, so now we're going to apply our Kirchoffs current law that we learned earlier, which is the current in a node must be equal to current out. So on this circuit here, I have all of our nodes labeled. And we see that we have 3 nodes. So we have all of our components here, and we have all of our components here, and all of our components that are touching down here. And what we're going to do is we're going to label this whole bottom part as ground. So the voltage at this spot is equal to 0, which makes sense because it's already went through all the components, so there's no more voltage left in the circuit. All right, so knowing that the current in must be equal to the current out, how are we going to find the current going left to right here? Well, since we have 6 amps here and nothing forks off, we know that the current here must be 6 amps. So what about these 2 spots here? Well, we're going to see that between V1 and V2 we have this 8 ohm resistor. And using our Ohm's law of I equals V over R, we can have our voltage difference, which we go left to right here, since our current is going left to right. V1 minus V2 over 8 ohms is equal to the current in that direction, left to right. And whenever we set these problems up too, we're going to want to have current. We're going to label our current leaving the nodes and entering the nodes. So I just had it entering here and leaving the, at these 2 spots here. And for V2, I had it entering over here and leaving here and here. All right. So now we want to find our equation for V1 going to ground. So like we did earlier, V1 minus our ground here, voltage, which is 0, over 6. So it's just going to end up being V1 over 6, since we do know that our ground voltage is 0. So if we set up some equations here, we can see the KCL for I1 is equal to our 6 amps in is equal to V1 over 6 ohm, our current here, plus V1 minus V2 over 8 ohms, which is our current right here. And this is all the current that we have going in and out of this node. So now let's figure out the KCL for I2. And we're going to have our current in right here, V1 minus V2 over 8 ohm, is equal to our V2 over 12 ohm, which I found the same way we did over here, plus our 5 amps. Now, if you simplify these equations a little bit, you're going to end up getting 6 is equal to V1 over 6 ohm plus V1 over 8 ohm minus V2 over 8 ohm. And on this bottom one, we're going to have something very similar. Now, to solve for these, the voltage on these nodes, we're going to do the same thing as earlier. We're just going to combine our V1s up here by finding a common denominator. And then we're going to combine our V2s down here by finding a common denominator and adding or subtracting one of these over. And once you do this, you end up seeing that V1 is equal to 16.6 volts and V2 is equal to negative 9.2 volts. So this means that the voltage over here is negative 9.2 volts and that the voltage over here is 16.6 volts. Alright guys, so I have a couple practice problems here for you guys. And on this first one, I just want you to find the voltage drop of this 2 ohm resistor. In the second one, I want you to find V1 minus V2 on this spot. For number 3, I want you to find the voltages of all the nodes. So you're going to have to figure out what all the nodes are and apply KCL. And on number 4, I want you to find the current seen in the 3 ohm resistor as if we're measuring it upwards. Alright guys, I hope that answered some questions you guys might have had. And I hope you learned a little bit about Kirchoffs voltage and current laws.